So guys, without wasting any further time, let us start with the first topic of this course. As you know that every networking course has to start with the introduction to OSI model and TCP/IP stack. So what exactly OSI model is? Since this topic is more of a theoretical nature, I will try to wrap up the theoretical portion of this course as fast as possible. Otherwise you will get bored and tend to lose interest. But at the same time, I will make sure that I cover every aspect of the theoretical portion of the course and comprehensively cover the course in its total entirety. So below is the OSI model. As you have already seen or must be aware of this OSI model. The OSI model actually comprises of 7 layers, as you can see. The lowest layer is the physical layer. After that comes the data link layer, then network layer, then the 4th layer is the transport layer, then 5th layer is the session layer. Then after that comes the presentation layer, and finally the topmost layer of the OSI model is the application layer. Now note the word that this OSI model is actually a theoretical model. It is just a reference, it is just a standard, it is just a guideline. Now let us go through the definition of OSI model and you will understand this point better, that why it is just a standard or it is just a guideline. So here is the definition of OSI model. Let us go through this definition. The Open System Interconnection Model. So the full form of OSI is Open System Interconnection. The OSI model is conceptual model. Note the word, note the highlighted words. It is a conceptual model. It is a concept that characterizes and standardizes. Note the word, standardizes the communication functions of a telecommunication or computing system without regard to its underlying internal structure and technology. So this is the definition of OSI model. And it says that it is just a standard. When we say that it is just a standard, it means the OSI model plays an advisory role. Advisory role means if somebody wants to implement its own networking subsystem, then he should follow OSI model as a conceptual design in mind in order to implement his own networking subsystem. The OSI model definition also says that without regard to its underlying internal structure and technology. That means that OSI model says that, hey, you want to implement your own data link layer, go and implement it. It's up to you that how you implement the functionality of data link layer. As long as you meet the goals of data link layer, we don't care. Use your own concepts, your own implementation, your own design. We are not bothered about the internal implementation of your data link layer, but as long as you meet the goals of data link layer, it's all okay. So this is what this line means, that OSI model do not define the underlying internal structure and technology in order to implement these 7 layers of OSI model. So remember, OSI model is a theoretical concept. It is just a reference. It is just a standard. It is just a guideline. Now let us see that what peoples have actually designed by taking this OSI model as a guideline. So now let us discuss some of the properties of this OSI model. So OSI model is nothing but it is a description of networking subsystem. The networking subsystem is called network stack. So you can see that this OSI model actually takes the shape of a stack. Why it is a stack? Because you can see the different layers of the OSI model are put over the one another, which forms a stack. And as I have already said that OSI model is just a guideline, right? Now each of these components in the OSI model, that is physical layer, data link layer, network layer, they are termed as layers. So what is the definition of layer? A layer is logically complete functionality of a networking component is referred to as layer. Now note the word logically complete functionality. It means that each layer is associated with a specific function. And these functions do not overlap across multiple layers. So for example, suppose network layer is associated with a function 1. That means that network layer has been designed and implemented to perform some specific function. Let us call that particular function is F1. Now, any other layer in this OSI model should not perform a functionality which has already been defined by function F1. It means that functions do not overlap. It means that each layer of the OSI model is associated with its well-defined functionality. Now, going forward, data or packet moves across the layers bidirectionally. That is, when the packet is received by the machine, the packet is picked up by the physical layer and moves upwards towards the application layer. And that happens on the receiving machine. Whereas on the other hand, while sending a packet, it is the application layer which generates a packet, and the packet then moves downwards from application layer down to the physical layer. Right? So while receiving a packet, the packet moves from physical layer upwards towards application layer, and while generating a packet, the packet moves from the top layer of the OSI model down to the physical layer of the OSI model. So we will discuss all this theory in pretty much detail in the coming slides. I am just discussing the overview of OSI model. Now all layers on this OSI model, as you can see, are stacked together to build a complete networking subsystem, right? So the Linux operating system that you are running, or maybe Windows operating system, it implements all these layers of the OSI model, right? So one of the most common example of OSI model implementation is the TCP/IP network stack, which runs inside your operating system. So remember, TCP/IP network stack is actually the implementation of OSI model. It is the actual implementation of OSI model which is actually running in your machine. And 99.99% of the machines in the world runs TCP/IP stack as networking subsystem. So let us try to emphasize on this point even more. You can see that on the left hand side we have our favorite theoretical OSI model, which is again just a standard or a guideline. Right? On the right hand side is actually the practical OSI model, that is the actual implementation of the OSI model which is actually running in your operating system. So what is actually implemented inside the operating system is called TCP/IP stack. And you can see that the design of this TCP/IP stack, that is the way the layers are stacked together on top of the other, is somewhat similar to that of OSI model. It means that this TCP/IP stack has been implemented by taking this OSI model as a guideline. So this TCP/IP stack is the actual implementation. So the OSI model has been brought to life by TCP/IP stack. Now you can see that there is actually a subtle difference. You can see that on the right hand side of the TCP/IP stack, there is no presentation layer, there is no session layer. It is because of this reason that the designer has chosen to implement the functionality of presentation layer and session layer as a part of application layer and as a part of transport layer. So in the actual implementation of OSI model, that is, in the implementation of TCP/IP stack, you will not find a separate folder or file which actually implements the functionality of presentation layer or session layer. The TCP/IP stack designers chose to implement the functionality of these two layers as a part of application layer and transport layer, right? So this is one difference between TCP/IP stack and OSI model. In the industry, the TCP/IP stack has been implemented this way, that there is no actual separate presentation layer or session layer. But the functionality of these two layers is very much present in the TCP/IP stack. So you can see this point that the presentation layer and session layer are partially implemented in the layers above it and below. So now, what are the type of questions that are asked from the OSI model? Now the questions that now I will going to discuss are the questions whose answers you will know when you will comprehensively complete this course. Because to understand the OSI model or TCP/IP stack completely, you will have to understand the functionality of each layer in the TCP/IP stack in pretty much detail. So the type of questions that are asked from the OSI model is pretty much everything that can be asked from networking. For example, let's say that the question number 1 is that given a protocol X, where X could be any protocol, let's say R protocol, ICMP protocol, HTTP or DNS or any other protocol, you will be asked a question that on which layer of TCP IP stack or on which layer of OSI model this protocol X operates. Right? Now you will be able to answer this question only when you have studied the functionality of protocol X in pretty much detail. Second type of question is that what are the changes happen in the packet content as it travels through the TCP IP stack during the course of incoming and outgoing packet journey. So as I have already discussed that when the machine receives a packet, the packet moves from the physical layer upwards towards application layer in the TCP IP stack. And when the machine generates a packet, that is, machine itself is the source of a packet, then the packet moves from the application layer down towards the physical layer of the TCP IP stack. So when the packet passes from layer above it to the layer below it, or when the packet passes from layer below it to the layer above it, there are always some changes that happen in the content of a packet. What are those changes? This is the question. So you will be able to answer this question only when you are thorough with the functionality of each layer of this TCP IP stack. Then the third type of question is what happens at each layer when a packet is received. So suppose in this TCP IP stack you have a network layer. So what will network layer do when it receives a packet from the data link layer? Right? And what will network layer do when it receives a packet from the transport layer? Right? So again, you will be able to answer such questions only when you understand the TCP IP stack functionality in pretty much detail. So coming back to the question, what happens at each layer of the TCP IP stack when a packet is received such that the packet is destined for a remote machine? And what happens when the packet is destined for the local machine? That is, the machine on which the packet is being received. So in this course, we will cover each layer of this TCP IP stack in a pretty much detail. I will try to cover every minute detail at each layer of TCP IP stack, and I will make sure that by the time you complete this course, you are absolutely thorough with the basic networking concepts, which are also a very much part of your academic curriculum. It is not a substitute of certifications, but this course is an enhanced version of your academic networking curriculum.